In 11th standard, we discussed the behavior of solids under the action of force, and we study about its property of rigidity. Now in this chapter we will have to study the property of liquid and gases under the action of force. The state of matter like liquid and gases are called fluids because they can flow. So we have to study the property of fluids under the action of force, such as viscosity and surface tension. Now this chart shows the synopsis or outline of this chapter. In this, the name of the chapter is Mechanical Properties of Fluids. Especially we have to study the about the fluids, just like air, liquid and gases. Now sometimes liquids are in rest position or in motion, and when the study of the liquids when they are at rest, at that time, that is called the hydrostatic. Now the hydrostatic is one of the branch of the physics, and when the liquids are in motion, then that branch is called the hydrodynamics. Under the branch of hydrostatic, we have to study the Pascal's law and surface tension, and under the branch of hydrodynamics, we have to study the viscosity and Bernoulli's theorem. Now we start to study the details of this chapter from the definition of fluid. A fluid means a substance that can flow. It is a substance that deforms continuously under the action of an external force. It is a phase of matter that includes liquids, gases and plasma. Now here the word deforms means to change the original shape. Now the liquids or the fluids changes continuously its shape under the action of external force, and it is possible in liquid, gases and plasma. Now the basic properties of the fluids are the shear modulus of fluid is 0, that is nothing but the modulus of rigidity is 0. A fluid flows under the action of force or a pressure gradient. Now here the word pressure gradient means the change in pressure with respect to distance, and its unit is Pascal per meter. Now shortly we can again explain the fluids. The fluids are in two positions. Sometimes they are at rest or in motion. Now the fluids when they are at rest, then that is called the hydrostatic, and the study of fluids in motion is called the hydrodynamics. Just we see that under the branch of hydrostatic we have to study the Pascal's law and property of surface tension, and under the branch of hydrodynamics we have to study the Bernoulli's principle and property of viscosity. Now here properties of ideal fluid. That first property is that it is incompressible. Now incompressible means its density is constant. Whatever the force is applied on the fluids, there should not be the change in density or volume of that fluid, and that is called the incompressible. Second is its flow is irrotational, that is the flow should not have the angular velocity, that is vector omega is equal to 0. Now it is non-viscous, that is there is no frictional force between the two adjacent layers of the fluid and has no viscosity. Now this property of viscosity we see in the hydrodynamics in next topics. Again its flow is steady or streamlined, that is its velocity is constant at each point in this time in a time. Now this topic is also we see in detail in hydrodynamics. Now ideal fluids can only be subjected to normal compressive state called pressure. Normal means the perpendicular force. Compressive stress is nothing but the force per unit area. Now this force per unit area is nothing but the pressure, and that's why it is called the compressive stress is nothing but the pressure. Now again we see the properties of the fluids, general properties. They do not oppose the deformation, they get permanently deformed, and they have ability to flow, and they have ability to take the shape of the container. They exhibit above properties because they oppose shear stress. In last year we see the definition of shear stress when in static equilibrium. Now the basic definition of the in chapter fluid is the pressure. A fluid at rest exerts the force on the surface of contact, and the definition of the pressure is the normal force exerted by a fluid at rest per unit surface area of contact is called the pressure of the fluid. Now according to the definition we can write the formula for the pressure. P is equal to normal force upon area, that is P is equal to F upon A, where F is the normal force and A is the area of surface area of the contact. Now SI unit of the pressure is Newton per meter square or Pascal. We know that 1 Pascal is equal to 1 Newton per meter square, and CGS unit is dyne per centimeter square. Other units of the pressure are bar, that is 1 bar is equal to 10 to minus 5 Newton per meter square. 1 torr is equal to 1 millimeter of Hg, and 1 hectopascal is equal to 100 Pascal. The dimensions of the pressure are m1, L raised to minus 1 and T raised to minus 2, and it is a scalar quantity. Now the practical units where they are used, that the pressure torr is used in the field of medicine and physiology, and the unit of bar is used in meteorology. Some relations are given here. The atmospheric pressure is equal to pressure exerted by 0.76 meter of mercury Hg, and it is equal to G H into rho of Hg, where G is acceleration due to gravity, H is the height of mercury column, and rho is the density of mercury, and its values are given. And if we substitute the values of all these, 9.8 is the acceleration due to gravity, 0.76 is the height of mercury column, and 13.6 into 10 to 3 is the density of mercury, and therefore 1 atmospheric pressure is equal to 1.0132 into 10 to 5 Pascal, or it is equal to 1.0132 bar, or it is equal to 760 torr. Now this all these are the conversions for your information. Now we have to find or we have to obtain the relation of the pressure with respect to related with the acceleration due to gravity, height, and density. Let us consider the vessel containing water, and consider an imaginary cylinder of water of height h and cross-sectional area A. A is the cross-sectional area of the cylinder. Let the density of liquid is rho, and the liquid column exerts the force F is equal to mg, which is its weight in the downward direction. Therefore, the pressure exerted by cylinder on the bottom of the cylinder is P is equal to F upon A. Here the value of F is equal to mg, and therefore P is equal to mg upon A. Now here m is the mass of that cylinder, and it is equal to density into volume, and density is the rho. A into h is the volume, where A is the area of cross section of the cylinder and h is the height of the cylinder. Substituting all these values of m in the above formula, and then we get G into rho AH upon A, where A and A gets cancelled, and then we get P is equal to GH rho, where G is acceleration due to gravity, H is the height of the liquid column, and rho is the density of the liquid. Now if you see the formula, P is equal to GH rho, here area of cross section is not, or it is absent. It means that the pressure exerted by a fluid at rest is independent of the shape and size of the container. It is true for the liquids as well as gases. Now, atmospheric pressure means what? You know, the atmosphere. The Earth's atmosphere is made up of a fluid, and you know the fluid is air, that is namely air. It exerts the downward force due to its weight, and the pressure due to this force of air is called the atmospheric pressure. The density of air in the atmosphere decreases with increase in height, and therefore the atmospheric pressure is highest at the surface of the earth and decrease as we go above the sea level. The atmospheric pressure at sea level is called normal atmospheric pressure. The region where the gas pressure is less than the atmospheric pressure and is called the vacuum. Perfect or absolute vacuum is when no matter, that is no atoms or molecules are present. Now this is all about the atmospheric pressure.